Yeah, welcome back. We are now on question number 2 of a normal question paper, which is paper 1, that is Newton's laws of motion. On the recent question paper, we were given this type of a question, whereby now they say block A with a mass of 4 kilogram, that is at rest, bolded. Now take note of that. Initial velocity is 0. On a rough horizontal table is connected to another block B of mass 8 kilogram by a light inextensible string passing over a frictionless pulley. A force F1 of magnitude 96 Newton is applied vertically upwards on block B as shown in the diagram below. You can see the diagram that's going together with the statement. Now, very important, the next statement. A force F2 of magnitude 75 Newton is now applied at an angle of 25 degrees with the horizontal on block A, and the block accelerate to the left. Underline that, because that will tell us a lot about friction and the direction of motion. The whole system now is accelerating to, in this case, in the direction of the clock, clockwise or to the left. The kinetic frictional force on block A is 11.76 newtons is given. Thanks. Ignore the effects of air friction. State Newton's second law. Remember, there are two definitions of Newton's second law. Learners have to know that. You can define Newton's second law in terms of acceleration, or you can define Newton's law in terms of momentum. Let's do the one of acceleration. It's simple. Just say, if you don't know it, write this one to say F net equals to MA, and A is directly proportional to F net and inversely proportional to this. In a nutshell, this is a summary. Just say now a net force acting on an object. Now accelerate the object in the direction of the net force. Direction of the net force. Please remember, working with the net force, not the force. In this case, and acceleration produced is directly proportional to the net force and inversely proportional to the mass of an object. We are in paper 1. Object plays a vital role, or a learner can use momentum to say the net force acting on an object. Again, a net force acting on an object is equal to, here using this F net equals to delta P over delta T. So from this one, net force acting on an object equals to the rate of change, in this case, of momentum, rate of change of momentum of an object object in the direction of the net force. Direction of the net force. That's how it should be. So you can define it in terms of acceleration or in terms of momentum. Know the two definitions. Whichever that you understand, you can use it to your benefit. Let's go to the next part. Now they are saying to us 2.2. They say, according to the question, draw a free body diagram for all forces acting on block A. You can see block A, according to the question, it's 5 marks. Therefore, it gives us a hint that forces acting on A, they are 5. What do we do? To make simple, they draw the surface, no problem. Just above the surface, draw a dot. Start with the weight, that's the easiest one, the weight. Or you can write FG, it's fine, it's acceptable. There's a rope, then this will be the tension. Again, there is the system is again to the left, then there will be also friction. Friction will be this as well. And then the other one is given. We are given F2, or you can write 75 Newton. And then there's a normal force. Normal force 1, 2, 3, 4, 5. It's 5. One learner can use an alternative way and say, no problem, there are many ways to kill a naughty cat. Then this can be the case. Weight, and then also have a tension, have friction, and then have the normal. Instead of this one, the learner now proactively just write Fy and Fx, so resolving the force into its component. Remember, in this case, Fy is F sine theta and Fx is F cos theta. This should always be in your mind. It's never going to be given, but you must know it. Fine, we are fine. 5 marks in the pocket and the 2 marks for definitions. We are going for 2.3.1. 2.3.1. They are telling us to say, calculate the magnitude of the acceleration of the block for 5 marks. Therefore, it's a multi-step question. We have to find the expression of Newton's second law on each block. Let's start with A, block A. According to this one, if you use this approach, very easy. The forces that are causing are active on the motion, they are the horizontal forces. Then we start with F net equals to MA. And then the object is acting to the left, therefore Fx will be positive, Fk negative, and T negative equals to MA. In this case, then we can substitute Fx, remember, is F sine cos theta, therefore it will be 75 cosine of 25 degrees. So you can see here that the angle is 25, the force is 75, and then minus friction is given. They told us that friction is 11.76 minus tension we don't know, then equals to the mass of the object is 4, therefore it will be 4a. Then we can simplify this one using a calculator. If you use a calculator, you'll find the expression here. That is going to be 56.21 minus T equals to 4a. We make this one equation 1, and then we go to block B. And then again use F net equals to MA. If we draw a free body diagram on B, hopefully you'll result with this one to say we have got a force, that is F1. We'll have a tension, and also at the same time we'll have a weight again. So we'll have three forces acting on B, because B is going down, therefore the tension and the weight, they are both positive, and F1 will be negative, it's acting in opposite direction. And then this will be your 8A, tension plus the weight is mass multiplied by 9.8, mass multiplied by 9.8, and then minus F1 is 96 equals to 8A. And then let's see what will be the expression using calculator here. Then we are going to find this continuation will be T, and then now minus 17.6 equals to 8A. This is equation 2. Remember, equation 1 was 56.21 minus T equals to 4A. So the question says calculate the acceleration. We can eliminate the tension, say equation 1 plus equation 2. Elimination method in maths, because I've got negative and positive, they will cancel out, and these two obviously will be 38.61. That's 56.21 minus this one equals to 12A. Therefore A at the end will be 3.22 meters per second squared. Fine, we get the 6 marks. The last question, which is your 2.3.2, obviously once you find the acceleration, they say calculate. Now can see the tension, calculate the tension in the rope. Now you go for any of these two equations, equation 1 or equation 2, and substitute, find the tension. T minus 17.6 if we use equation 2 equals to 8A. Therefore T minus 17.6 equals to 8 into 3.22. Therefore, if you use your calculator very well, in this case you can tell that our tension should be 43.36. We'll have a range here, so don't worry if you get 43.33, then we'll have a range that it will be acceptable. So that is how to calculate. Remember, in this case we are using what you call positive marking. Even if these expressions were wrong, or even this acceleration is wrong, if you use this one correctly here, we'll get the 2 marks here. One mark for substitution, 1 mark for the answer. You will get the 2 marks in this case. That is all about the Newton's laws of motion. Hopefully you have gained a lot here, especially to say when you draw a free body diagram, the forces that are in the same direction as motion, they are positive. The ones in the opposite direction, they are negative. Then that will inform when you are dealing with F net equals to MA. So until we meet in the next session, thanks a lot for now.